Okay, so today we are going to start May-June 2020 paper 5-1. Question number 1. Trichloromethane and propanol are both organic liquids. The molecule liquid are attracted to each other by a relative weak permanent dipole-dipole interactions. Okay. When trichloromethane is mixed with a propanol, a strong electrostatic attraction forms between two different molecules. And here you are observing the attraction, and we know these are intermolecular attraction or intermolecular forces. Okay. A student plans to perform an experiment to investigate the strength of these electrostatic attraction by finding the temperature change when equal volumes of trichloromethane and propanol are mixed together. State and explain your prediction for the temperature change for this experiment. Okay. So, what the student did, that it has to, the objective is to investigate the strength of this electrostatic attraction. Yes, it's paper 5. I have shared in the group, Hassan. Experiment to investigate the strength of this electrostatic attraction by finding the temperature change. Okay, so what they are saying, when the equal volume of trichloromethane and propanol are mixed together. Okay, so when we mix it, what will happen? There is this attraction which is over here is going to form when these two are mixed with each other, right? So it means it's a sort of a bond forming, and whenever the bond forming occurs, energy releases, right? And when the energy releases, what happens to the temperature? Temperature increases. And if we compare the forces which are between trichloromethane, which are obviously weaker than this one because there is a dipole over there. Oxygen, the electronegativity difference between oxygen and hydrogen is relatively high. So if it's high, so this attraction would going to be the stronger as compared to the attraction between the propanol molecules and the attraction between the trichloromethane molecules. So that's why, as these attractions are stronger, so the temperature change would be that there is an increase in temperature. Is this understandable to all of you? Yes. Okay. So the thing is, it's CH3Cl, right? So there are, in the sample of trichloromethane, there are these molecules only. And in the sample of propanol, there are these molecules only. Is this understandable? So there are some attraction over here. So if you see, there are the attraction over here. There are intermolecular forces between propanol molecules as well. And there are intermolecular forces between, okay, I have written the wrong formula. It's CHCl3. There is the attraction between these molecules, the trichloromethane molecules, and there is this attraction between trichloromethane and propanol. So basically, if you see these two, their electronegativity difference is relatively very high. So it means this attraction would be stronger than these one. Now, is this understandable? Yes, Mariam, did you understand? So we have to state and then explain. So what I am going to state, that there is increase in temperature, and now I have to explain. In attraction in propanol is induced and permanent both. Okay. And same case with the trichloromethane, but between trichloromethane and propanol it would be permanent only. So we will write that. Now we will explain that the electrostatic attraction between different molecules is greater, or you can say stronger, than the attraction. Yes, yes, yeah. Then the attraction between same type of molecules. Yes, is this understandable to all of you? Now, next part. The student is given only the following equipments and chemicals for the experiment. Okay. One to 25 centimeter cube beaker, two thermometers, two 25 centimeter cube measuring cylinders, 50 centimeter cube trichloromethane, and 50 centimeter cube propanol. Outline the method the student should use in this one experiment to find the temperature change when trichloromethane is mixed with propanol. Give details of the volumes, liquids used, and any reading taken. Okay. So the volume that we are going to use, we are going to measure it with the measuring cylinder. But see the beaker. What is the volume of beaker? That is 25 centimeter cube. So it means that the both, when we mix both the solutions, their volume must be lower than this. This one. Is this understandable? So we can write that equal volume. Yes, that's possible, Abdullah. Of both the solutions, but total volume must be less than 25 centimeter cube. No, you can't fill it whole. You have to keep it lower than that. So what readings we are going to take? We are going to observe the temperature change. That's what the examiner have discussed. So it means uh, we have to record initial temperature, right? of both the liquids. Then final temperature after mixing. Then method used. Okay. So mix both the solutions in beaker and keep checking or monitoring the temperature until it start to fall. So basically the temperature rises, but the temperature after rising it starts to fall again. So we have to note the highest temperature. So we have to check the temperature at intervals until it starts to fall. Is this clear? Yeah, I have to write regular. That is important because we will keep checking the temperature. Okay. Till here, if any one of you has any question, please ask. It's clear to all of you? That is the calculation. We are just talking about method, Abdullah. That's what we do in the calculation, right? Okay. The apparatus used leads to significant heat loss. Stage one improvement, the student could make the apparatus to reduce heat loss. So we have used beaker, right? Both solutions are at room temperature, so obviously both solutions have the same temperature, isn't it? Yes, anyone? Yeah, we can use polystyrene cup. Not, you can't write insulator. Okay, instead you have to write polystyrene cup, or you can use it. We are using beaker, so cover the beaker with the lid. So that's what we can do as well. So either you can write anything. Cover the beaker with the lid, or instead this use polystyrene cup. Is this clear to all of you? Trichloromethane and propanone are both volatile and flammable. State one relevant precaution that should be taken when carrying out this experiment. Read the question again. Yes, very good, Asif. So there must be no naked flame over there, or instead you can write, we can use an electric, heater. Yeah, don't heat using a Bunsen burner. Yes, that's also correct, Amarju. See, they have told you initially, they have given you the information that volatile and flammable. So if they are flammable, so it means there must be no naked flame. Here must be one here. Solutions. Okay, next part. State one change apart from reducing heat loss that could be made to improve the accuracy of this experiment. Yes. Okay. Shahan, but there is some issue. Yes, what different apparatus? Okay, let me recall you guys. If you recall, measuring cylinder is always for the approximate reading, right? So instead of a measuring apparatus, what we can do? Which apparatus we can use? As in it's at a constant room temperature, we are performing. There is a no heating provided initially. Volumetric flask is not for the measurement, it's for making the preparing the solution. Yes, Abdullah, you are correct. So the correct proposition over here would be using burette, because burette is used to measure the volume accurately, right? And measuring cylinder is used to measure the volume uh, approximately. So using burette or use burette instead of measuring cylinder. Is this understandable? How can you use a more sensitive thermometer, Rahmat? We can use more accurate thermometer, and larger volume can also be an answer, Shahan. Because obviously, if we use a larger volume, then the percentage error must be decreased. So that can be answer for this as well. And more accurate thermometers can be used. Like you can use a digital thermometer. Okay. Now, next part. In another experiment, a student uses 37.50 gram of trichloromethane and 19.75 gram of propanol. Okay. And determines that the energy released is 1.67 kilojoule. Calculate the number of moles of each compound in this mixture. Okay. So it's easy. They have given you the MR values of both. So if I have to find the number of moles, so the number of moles of trichloromethane would be its mass 19.75 divided by its MR, which is 119.5, and number of moles of propanol would be 58.0 divided by, sorry, no, never mind, sorry. The mass of the trichloromethane is 37.50 divided by its MR, which is 119.5, and moles of propanol would be it's equals to its mass, which is 19.75 divided by its AR, which is 58. Now, for the first one, is it 0.314 as Muhammad Qureshi said, 0.314, and for second one, 19.75. 0.3405, Shahan. So it is going to be 0.341 because we always write in three significant figures, right? So 0.314 and 0.341. Is this understandable to all of you? Why? We always use grams in moles formula. Okay. Now next part. Calculate the enthalpy change delta H of the electrostatic attraction form between trichloromethane and propanol. You must include a sign in your answer. Okay. Now if you see in this attraction, the diagram they have given you, what is the mole ratio of these two? Yes. What is the mole ratio of these two? 1:1. So it means if there is a 1 mole of trichloromethane with 1 mole of trichloromethane, 1 mole of propanol would be going to form a electrostatic attraction, right? Now, if you see over here, are these two have a same number of moles? No. So it means this one has a greater mole. So it means it's the one which is in excess and it's the one which is the limiting. Is this understandable to all of you? So it means that whatever the enthalpy change, the energy which is released over here is due to these number of moles which are less, which are limiting reactant. Is this clear? So see, we got one ratio from the previous one, 0.314 is to these number of moles are providing me 1.67 kilojoules of energy. Is this understandable? Now, if you see the unit, they have asking you kilojoule per mole, which means how much energy is produced or is released by 1 mole. So here, I'll keep it 1 mole. And for 1 mole, how much energy is released? It's X. So the energy is released. They have asked you to include an X sign. So it would be negative always. So calculate it 1.67 times 1 divided by 0.314. Yes, can anyone tell me the answer? Order is for a chemical reaction. Here, there is no chemical reaction taking place, Shahan. Here, just the attractions are forming. So, how could we say a order? Because there is no new product is forming. Nothing is being used up. There is just an interaction which is being developed between the two different substances. Yes, so its answer would be minus 5.32 kilojoules per mole. Till here, is this clear to all of you? What we have initially decided, Abdullah, that the energy is being released, right? So that's why minus. Mariam, it's simple maths. If you see over here, they have told you when this and this much grams are mixed, this energy is released. Then they have asked you to find the moles. When we calculated the moles, we got this. These are the moles. So we concluded as these moles are lesser, so it means these are the moles due to which this amount of energy is released. Till here, is this clear to you, Mariam? So See, I just made a ratio that these number of moles are producing this much energy. So if we have a 1 mole, then how much energy is produced? So if this is X is the energy produced for 1 mole, so isn't it? It becomes a kilojoule per mole. Is it understandable? So that's what we did. Take a just simple ratio. Now, okay. Suggest an experiment the student could carry out to test whether the number of moles of trichloromethane affects the temperature. Yes. How could we do this? Suggest an experiment the student could carry out to test whether the number of moles of trichloromethane affects the temperature. Yes, what Sean, you are saying propanol to be constant and vary trichloromethane. Vary volume of a trichloromethane, keep volume of a propanol same. Yes, that's what we can do. But yes, Vahish, change the number of moles is considered to be correct, but how you could change the number of the moles of trichloromethane? By changing its volume, right? We have to take the different volume. Is it understandable? So what we will do, change the volume of trichloromethane and keep the volume of propanol same and check the change in temperature. Is this clear to all of you? So here we have ended with the question number 1. Now let's move to question number 2. Okay. Nitrogen dioxide can be prepared by strongly heating anhydrous like nitrate. The thermal decomposition occurs according to the equation shown. Okay, so this is the equation that you have studied in AS as well. The nitrogen dioxide can be separated from the oxygen by cooling the gas mixture produced until the NO2 condenses and oxygen does not. Okay. Yeah, if you see the boiling point of nitrogen is higher. So when we cool it, it will condense first and it will condense at even more lower temperature. So we can keep the temperature lower than 293 and higher than 90 to make nitrogen dioxide condenses only into a liquid and nitrogen escapes as a gas. Is this understandable? Now what they are saying, draw a label diagram of the laboratory apparatus assembled. Okay, it means it must be arranged. That could use to prepare liquid nitrogen dioxide from the thermal decomposition of anhydrous lead nitrate. Okay. So if it's, if you have to collect the gas as a liquid, we have to put, for example, here we put lead nitrate, and here we keep the burner to provide the heat. There is a bung over here, so the gas would not escape, and there is a tube, and the gas can only passes through the tube. So this tube enters in a U tube. Now see what is the benefit of putting of this U tube. So here we have another one. So see, we keep this in a container, and that container contains a cool water. So see what happens when we heat it over here. When we heat it over here, the two gases, nitrogen dioxide and oxygen, escapes, right? On decomposition. So they move and enter over here. And when they reaches over here, due to a cool temperature, the nitrogen dioxide gets liquefied and oxygen can get from here. Is this understandable to all of you? You can use cold water or iced water. And from here, the oxygen escapes, and here the liquid we got NO2 and in the condensed form. Yes, is it clear to all of you? Just give me a minute, please, everyone. Okay, yes, Hassan. See, it's 90 Kelvin, right? And it's 294 Kelvin. So when you convert it into a degree Celsius, so 294 minus 273, can you tell me the answer? And here it's 90 minus 273. So see that it's the temperature obviously gets in the negative. So if it's a cool temp water, so it must be 10 degrees Celsius or something like this. So which must be lower than this. If you subtract it, what you are getting? Is it 21? Yes, is it 21 degrees Celsius? And what is the temperature over here? That if you subtract it, if you convert it into a degree Celsius, is It's minus 183. So do you think cold water can go below minus 183 degrees Celsius? So that's why only NO2 gets condenses, because the temperature is, for example, in a cold water, it's 10 degrees Celsius, which is lower than 21. So as the temperature gets lower than 21, the nitrogen dioxide condenses in a liquid. Is this clear? Okay. Now, at room temperature, nitrogen dioxide exists in equilibrium with dinitrogen tetroxide according to the equation. Okay. For this equilibrium, okay, that is the Kp expression that we have studied in AS. Partial pressure of dinitrogen tetroxide and partial pressure of NO2 nitrogen dioxide are measured in kilopascals. State the unit. Okay. So see, if you see over here in kilopascal, so in the numerator we have a partial pressure of nitrogen tet dinitrogen tetroxide. So its unit would be kilopascal. And in denominator, it is square of the partial pressure. So it means it's kilopascal square. So I would left with 1 over kilopascal, which means kilopascal inverse. So the unit of Kp would be kilopascal inverse. Is this clear? Yes, Muhammad Azaf, very good. Okay. Now, next part. A student plans to investigate the variation of Kp with temperature. Okay. A sample of the mixture of nitrogen oxides is introduced into a gas syringe at 295 Kelvin, and the gas syringe is sealed so that it is both airtight and watertight. Okay. The volume occupied by the mixture is measured at different temperatures. The Kp value is calculated at each temperature. Okay. So we have to use a different temperatures. Which diagram? Yes, Ahmed, see the diagram. Okay. Name the apparatus you would use to heat the gas syringe at different temperatures between 295 Kelvin and 370 Kelvin, so that the volume reading of the gas syringe could be easily taken. So see, we have a specific range of temperature and we have to maintain different temperatures in between. So for that purpose, and if you see, it's 370 Kelvin. So it's 370 Kelvin, it's 295 Kelvin. So do this. Just do this and tell me the answer. 295 minus 273 give me the temperature in Celsius. 370 minus 273. It's 97 degrees Celsius, right? And the above one? Yes, Shahan, thermostat. We can actually use the term thermostatically controlled water bath, because see, the maximum temperature we need is 97, not 100. It's below 100. So we use a water bath. So, and thermostatically controlled water bath, because the maximum temperature we need is must be lower than 100. So only in water it gets lower than 100, because as soon as it reaches water, at 100, water itself boiled and turned into a gas. So thermostatically controlled water bath. Is this clear to all of you? Okay. Now, part 2. The results are obtained are shown in the table. Complete the table by calculating the values for 1 over t and log kp. Record the value of 1 over t to 3 significant figures and kp to 2 decimal places. So you have to divide 1 by 377, then 1 by 361. Do it quickly and tell me the answers in 3 significant figures. Okay. So the first answer I got is 0.00265. Next one, 0.00277. Yes, next one. Yes, next value, please. 1 divided by 344. Okay, 0.00291. Next value, please. I think all the values must be 0.00. Okay, 0.00303. Next one. Okay, 0.00317. Next one, please. Zero point double zero three two one. And the last one. Zero point double zero three nine. Okay. Now you have to take the log of these values. Who is going to take the log and tell me the answers, please? Yes, can anyone taking the log and okay. Minus 1.111 minus 1.12. Now the second one. See, Mariam and Ahmed, it's my, you have to take 2 decimal places. That's what examiner says, right? And you are guys are taking 3 decimal places, so you will not going to get the mark. Minus 0.91. Okay. Minus 0.59. Next one, please. Minus 0.13. Next one. Zero 0.18. Okay. Yes, next one. Only 2 are left. 0.54. And the last one. Okay, 0.96. Now, plot a graph on the grid of log Kp against 1 over T. Okay, reciprocal. Draw a line of best fit through the plotted points. Okay. So 0.00265 has minus 1.12. So it is going to be this one. 1.12. So 1.12 is going to be over here like this. Then we have 277 and 0.91. 277 is over here and 0.91. 0.91 would be this point. Then, I'm sorry, 0.9. I think I did some, yeah, this is a mistake over here. Thank you. Okay, so we have plot 1.12. So 1.12. So 1.12 would be over here, right? Yes. Then we have 0.277 and minus 0.91. So minus 0.91 would be over here. Then the next one is 291 and 0.59. 291. 291 and 0.59. So 0.59. Then next one have 303 and 0.13. 303. 303 and 0.13. So 0.13 would be over here. Then 317 and 0.18. 317. So 317 would be over here and 0.18. So it's 2.18. 0.18 would be over here. Then we have 321 and 0.54. 321 Okay, and 0.5, it's 0.5. 4, 3, 2, 1, 3, 2, 5, 4. So 0.5 is over here, and 0.54 will be over here. I hope you guys are getting this scale. Then 339 and 0.96, 339. So 339 would be over here, and it's 0.96. So 0.96 would be this one. So this is the plot we got. Now we have to draw the line of best fit, right? Okay. So that's what I get. That would be the line of best fit. Now, if you see, there are many points which are going outside. Let's see. We have this point, and this point, right? So there are 3 points which are not on the line. So what they are saying in the next part, state and explain what your graph shows about the accuracy of the experimental results. So if we talk about the accuracy, we can say that not accurate because the points are not online. As points are scattered and not on the line of best fit. Is this understandable? Okay. Now they are asking, suggest a reason for your answer in D1. So see that if we talk about Kp is the one which we have calculated at different temperatures. And they are asking about the experiment. So it indicates that there would be a difficulty in measuring the temperature accurately because we are not able to record the temperature accurately. We did the error in measuring the temperature, and that's why our results are getting uh, that is scattered. Is this understandable? It's difficult to record the temperature accurately. Now, suggest what the student could do to improve the accuracy of the experiment. So the one way is that you can repeat and take the average. Anomaly occurs, Shahan, when there is only one point which is different from the line of best fit, but there are many multiple points which are differ from the you know line of best fit. So that's why we can't remove anomaly. So we have to repeat the experiment. So you have to repeat the experiment and take average. Now what they are saying in the next part, use the graph to determine the gradient of the line of best fit. State coordinates of both points you used in your calculation. These must be in your line of best fit. Give your answers to three significant figures. Okay, so we have to find the gradient. So let's take the coordinates first. Let me take this as a one coordinate. So it's 0.00274 and -1. 0.00274 and 1.00. Now coordinate 2. If we take this one, it's 0.00284 and 0.70. 0.00284 and 0.70. So 0.70 minus 1.00 divided by 0.00284 minus 0.00274. Can anyone calculate and tell me the answer, please? Yes, can anyone tell me the answer, please? It's minus 11.69. Okay, but it's not minus because both the values are in minus, so it would become positive. So 11.69. Okay, why there is so much difference? Mariam is getting 3,000. Yes, can anyone confirm me? What is the correct answer? 3000 or 11.69? Asif and Shahan, can anyone check, please? Please do this quickly. Asif is 17,000. Let me check. That's 3,000. Yes, it's 3,000. Okay. Now, the relationship between log Kp and 1 over T is given by the equation shown. R is 8.31 joules per Kelvin per mole. Okay, it's a great constant, gas constant. Use the gradient determined to calculate the value for delta H. So if you look for a gradient which is y2 minus y over x-axis, so y is log Kp and x is 1 over T, right? That is x and that is y. So y-axis is log Kp and x-axis is 1 over T. So gradient would be log Kp, gradient is slope over 1 over T, right? So which would become finally log Kp into T. Is this understandable? We are doing it log E2. See what we just did? We just identified that y-axis is log Kp and x-axis is 1 over T. So gradient is y over x. So y is this and x is this. So it's 1 over T. So that T moves over there in the numerator, making the gradient log Kp times T. Is this clear? Now, if you see this equation, isn't it log Kp is equals to minus delta H divided by 2.303 RT. So if I move the other things over there, so wouldn't we become delta H is equals to log Kp T times 2.303 R. So see, this becomes gradient, right? And we calculated the gradient. Is this understandable to all of you? So delta H is equals to 3000, that is a gradient, times 2.303 into R, which is 8.31. Yes, negative sign as well. Sorry, my bad. Yes, can anyone calculate and tell me the answer, please? So it's 57,000 minus 57,400, right? Now, what we are asking, With the reference to the results obtained in this experiment, state and explain Kp varies with temperature. How? Okay, so if you recall, that's what we have studied in AS. If the reaction is exothermic, then if the temperature increases, then the Kp or Kc value decreases. So this reaction is exothermic, isn't it? So on increasing the temperature, Kp value decreases, and it's because the delta H is negative, or you can say that the reaction, the form is exothermic. So Kp is inversely proportional. That's what we have studied in equilibria in AS. You guys look at these notes, so you will find that Kp on increasing the temperature, if Kc or Kp rises, then it means it's an exothermic reaction. Oh, sorry, endothermic reaction. And in exothermic reaction, if we increase the temperature, the Kp and Kc value decreases. So here, the reaction is exothermic, the delta H is negative, right? So it means on increasing temperature, Kp value decreases. So Kp is inversely proportional to temperature as delta H is negative. Is this clear to all of you? Now, last part. With a reference to B and the data for Kp in the table in C2, suggest how the color of the equilibrium mixture at 370 Kelvin will differ. It will differ, if at all, from the color at room temperature. Explain your answer. Okay, we know that the reaction is exothermic. So we have to compare the color at room temperature and at 370 Kelvin. So it means at 370 Kelvin, we increases the temperature. The temperature is higher, right? So if you see over here, its delta H is negative. So at 370 Kelvin, so the temperature is high. So the temperature is high, it means equilibrium shifts to the back. And if equilibrium shifts to the back, it means what will be the color of the solution? The color of the solution becomes even more NO2 with form, so brown, and even more brown or darker brown. Is this clear? Yes, Mariam, what is your problem? What you didn't understand? So color gets darker brown or dark brown, because we are talking comparative, so we must write darker brown. And explanation is that equilibrium shifts to left. 1 minute, I will explain your query. Equilibrium shifts to left at 370 Kelvin. So the thing is, what they are saying, with the reference to your result obtained in this experiment, state and explain how Kp varies with the temperature. So they are saying on the basis of this, you can conclude. So that's what we have studied in AS. You have to understand this. Let me show you. I got the notes over here. Where is it? Yeah, here. See, we discuss it over here. See, if the reaction is exothermic, yes, Mariam. If we increase the temperature, what will happen? Equilibrium shifts to the left, and as a result, Kc and Kp value decreases. So see, temperature is increasing and Kp value decreases. So isn't it the relation is inversely proportional? So, and it's for exothermic reaction, and exothermic reaction means that the delta H value would be negative, right? Isn't it? So see, that's what we did over here. That Kp is inversely proportional to the temperature, because I concluded this from this result that the delta H is negative, which means that the reaction is exothermic. And if the reaction is exothermic, then it means when the temperature is raised, the Kp value will decrease. So that's why I have written it's inversely proportional, because the delta H is negative. Is it clear now? Yes, if any one of you has any query, we have completed another paper 5. Okay, I'll try to do one more paper 5 tomorrow, and then we will move to the paper 4, because I think you guys have a paper 4 earlier. So we'll attempt paper 4, and then after then we will practice paper 5. Okay. So see you everyone tomorrow, inshallah. Take care. Goodbye. Allah Hafiz.